Hi, scholars. Welcome back to another exciting chemistry video lessons by Adrenaline, the Bazooka Prophet. Now, and in this exciting video, we're going to be talking straight away to some questions that are frequently asked in organic chemistry. Now, we have been doing a series of questions in organic chemistry. Now, this is the part 3 of our video lessons in organic chemistry, whereby we tackle questions for students who are preparing for any examination. You're writing WAEC exam, you're writing JAMB exam, you're writing any undergraduate exam or any international exams, be it IB, AP, IGCSE examination. So quickly, we go straight to the questions so we can tackle the questions. Now, the first question says, how many sigma bonds are in 1,3-butadiene? How many sigma bonds are in 1,3-butadiene? Options are A 3, B 6, C 9, or D 12. As you can see, before we talk about the answer to the question, we should understand the types of bonds under covalent bond. Now we should understand that sigma bonds and pi bonds are types of covalent bonds found between atoms in a molecule, right? Now, the first thing for us to do is to draw the structure of 1,3-butadiene, which is like this. So here is 1, 2, 3, 4. Now, this is the chemical structure for 1,3, right? 1,3-butadiene. Now, in this organic structure here, take note, we were asked to indicate the number of just sigma bonds. Now, take note, for every single bond, we have a sigma bond. For every double bond, we always have one sigma, one pi. For every triple bond, we always have one sigma, two pi. Please do not forget that. Now, there is a single bond here, so we can have one sigma bond here, another sigma bond here. Take note, remember I told you that for every double bond, we have one sigma and one pi. There is a single bond, sigma, 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 one pi, sigma, sigma. So when we count the number of sigma bond here in this molecule, right? So it means that you should be able to write the structure before you can then indicate the sigma and pi bonds when asked in a question. I hope you're following, right? It's easy. So 1, 2, 3, 4, 5, 6, 7. Okay, 1. Oh, they ought to be, see it now, right? So here is also another sigma bond, because remember, a carbon must be tetravalent. So here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the total number of sigma bonds in this structure, buta-1,3-diene or 1,3-butadiene, is 9 sigma and 2 pi. But note, we will ask for just sigma. So the final answer becomes what now? C, which is 9 sigma what? Bonds. So I'm going to be erasing this board here. Please look at the structure. I'll be erasing so I can create more space to do others. Okay. Okay. So the first question is solved. Then we move to the next question, which says, what are the products of the equation below? We have calcium carbide with water, and you are giving question mark here. And the options are A, acetylene and calcium hydroxide, acetylene and calcium oxide, carbon 4 oxide and calcium oxide, D, none of the above. Now we should understand that this particular reaction is the laboratory preparation of ethyne. IUPAC name is ethyne, but the trivial name is called acetylene. Now we should understand that ethyne is prepared in the laboratory by the action of cold water, by the action of cold water on calcium carbide. And when that is done, two products are always involved. And the products are, we have first of all calcium hydroxide and what now? And ethyne or acetylene. So that when I balance it, this is what I have. So therefore, the final answer is what now? Is A. But we should understand that when we go a little bit deeper into it, we understand that when these products are released, it comes with a lot of heat. A lot of heat are evolved or are eliminated alongside with it, and this comes with a lot of impurities. Now, the impurities are majorly calcium what? Phosphide. Calcium what? Phosphide. There was a question that was asked for undergraduate students that these impurities can be absorbed. Now, these impurities is calcium phosphide, which produces phosphine. So phosphine gas is one of the impurities involved during the laboratory preparation of what now? Of ethyne. But what can then be used to absorb these impurities? The name of the compound is called copper 2 sulfate, or some tests will tell you acidified copper 2 sulfate. For those of you making use of the first year organic chemistry used in the university of used in Nigerian university, precisely the one around us here. If you open to page 90, right, third edition, line 4, you will see where it was stated copper 2 sulfate is the name of the chemical used to absorb these impurities, calcium phosphide, which produces what now? Which produces phosphine gas. Now, when you go straight down to your NIS 2 chemistry, for those of you who are preparing for JAMB exam, WAEC exam, POST-UTME examination, you can check it in page 537, right, in your 2016 edition. Of course, the same line 4, you will see all this information stated there, right? So let us go deeper to some other aspects about it. Now we know that the action of calcium carbide on cold water, we produce what now? We produce calcium hydroxide, which is aqueous, and acetylene, which is what now? Which is a gas, right? So I will erase the board so I can create more space to solve or take care of the other questions. Now, I actually love this last question, right? Now, what does it say? What is the major product of the reaction given to us here? This is what we call propyne or prop-1-ine, right? When we react it with HCl, what are the products that can be obtained? Now, this kind of question falls under what we call the use of Markovnikov rule, because if you check this compound here, the compound or this organic compound is not symmetrical, meaning it is unsymmetrical, and you are adding an heterogeneous atoms. So what do? come here from having something like this. Okay, so let's do it. So I'm adding two molecules. So if I'm adding two molecules to it, it simply means that it will be converted to give me a saturated what compound. So what do I do here? Simple. My interest is between these two. Remember, according to Marconico rule, right? The one with lesser, with fewer the carbon that has more hydrogen, right? The hydrogen coming from this reagent will be attached to it. So what do we do here? So it will break. So I'm having between this carbon here and this other carbon here, right? So at the end of the day, when HCl is added to this triple bond, it will first of all convert it to give me this. If I use one molecule here, I will have CH3, C, having something like this, yeah. Okay. This is the intermediate, which is what now? Which is 2-chloropropene. When I add just one molecule, right? If I add another molecule to it, the final product will give me again, of course, the same rule, the same Marconico rule. We're having Cl here, Cl here, then the final product here is this. So the final answer here is 2,2-dichloropropane. And that makes the final answer to be what now? To be C. And this is the reaction pattern of this question. And remember, humble self and adrenaline, the bazooka prophet. Do well to subscribe, like, and share. And of course, if you have any question or you want a live Zoom class which is currently ongoing, where we give out many questions and take it deeper, of course, you can write me up on this WhatsApp number. Thank you and God bless you.